Hello and welcome to Database Management Systems. I'm Jovita Christie, and in this video, I'm going to explain to you transaction management, concurrency control. So we are going to discuss two protocols, which are lock-based protocols and timestamp-based protocols. So let's first begin with lock-based protocols. In a lock-based protocol, there are two types of locks. The first type of lock is known as a shared lock, and there's another lock which is known as exclusive lock. A shared lock is a lock that can be shared by multiple transactions, and a lock-based protocol works in a way in which one transaction can obtain a lock on a data item, and if that transaction is working on that data item, then obtaining a lock is compulsory. So if a transaction only wants to read the data item but does not want to perform any changes to it, then that transaction can obtain a shared lock. And to obtain a shared lock, it doesn't matter if there's some other transaction also having a shared lock on the same data item. So that is a shared lock. An exclusive lock is a lock that allows the transaction to read as well as write a data item. And so an exclusive lock is a lock that is exclusive to one transaction. So if one transaction holds an exclusive lock on a data item, then another transaction cannot at the same time hold an exclusive lock. And also if there's an exclusive lock, you cannot have a shared lock with it. And we're going to see that now with something called a lock compatibility matrix. It looks like this. So what you see here, wherever it's written S and X, S stands for shared lock, X stands for exclusive lock, and on top you can see the same thing happening. And here you can see true, false written. And true is written only in one position. This is because the shared lock is compatible with only a shared lock, which means if one transaction is holding a shared lock on one data item, for example, A, then another transaction can also obtain a shared lock on that data item A. But if we are talking about exclusive locks, then if one transaction holds an exclusive lock on a data item A, then another transaction can neither obtain a shared lock nor an exclusive lock on the same data item due to incompatibility. And that is how the locking system works. Now you can see on your screen right now, there is an example of how locking works in practice. So in this case, there's a transaction T1 and there's a transaction T2, and then there's a concurrency control manager. So what happens here is that whenever the transaction starts and it knows right here that it wants to read this particular data item B, then the transaction is going to obtain a lock first. Now, in this case, the transaction doesn't just want to read the data item. The transaction also wants to write. So you can see there's a read operation and a write operation. So that is why what happens here is the transaction obtains an exclusive lock, not a shared lock, because it knows that eventually it's going to write. So there's an exclusive lock, which is written here, lock XB. And on the other side, you can see there's a concurrency control manager. So this is basically a mechanism that checks, if a transaction wants a lock, then this concurrency control manager is going to check if that lock is available and if it is compatible with other locks held on the same data item. And if it is so, then the request will be granted. As you can see, it is written grant X B on TI, which is my T1, which is on my first transaction. So T1 is given access to this X lock. X lock stands for exclusive lock on the data item B. So you can see that once the read is over and the write is over, then the transaction is going to unlock that data item so that other transactions can access it. And you can see once that is done, then there's the transaction T2, and that T2 is first obtaining a shared lock on A, which is once again granted by the concurrency control manager after performing all the compatibility checks. And then the transaction T2 will read data item A, unlock that data item, and then obtain a shared lock on B. Now, at this point, T1 has already unlocked B. So there is no point in waiting for T1 because it has unlocked. And so the concurrency control manager will give access to that lock. And once that is obtained, this transaction is reading B and then unlocking B and then simply displaying A plus B. And you can see that then once again, this transaction T1 is trying to get an exclusive lock on A, which is also granted by the concurrency control manager, since no other transaction is holding that lock. And once all that is done, then this transaction is going to read A, subtract 50 from A, and then it's going to write A, and then it's going to unlock A. So this is an example of the locking protocol in practice. However, when we want to perform locking, we don't just perform locking in this manner. We also try to follow some rules, some protocols which can help us to make this scheme better. So one such protocol is known as a two-phase locking protocol, and that's what we're going to see now. So two-phase locking protocol has two phases, as the name suggests. The first phase is the growing phase, where a transaction can only obtain locks. And the second phase is the shrinking phase, where a transaction can only unlock. So once again, the growing phase, where transaction can only perform lock operations, and the shrinking phase, where the transaction can perform only unlock operations. So it just means that once the transaction starts locking, then the transaction won't unlock. But the minute it starts unlocking, after that point, it cannot lock anymore. This transaction right here does not follow two-phase locking protocol because you can see there's a lock, exclusive lock on B, and then unlock B is done, and then again there's a lock on A. So this is a process where all the lock operations are not coming together in one phase. And after doing unlock also, another lock is being obtained. So this transaction right here does not follow a two-phase locking protocol. Let's see an example where the two-phase locking protocol is followed. So this is one such example. You can see there's a lock XB. After that, there's a lock XA. And then in the end, we have unlock B and unlock A. So the unlocking process is done after all the locks are obtained. So this transaction follows the two-phase locking protocol. Now the point at which the transaction obtained its last lock. So this is my first lock, this is my second lock, and after that there are no more locks being obtained. So this is also my last lock. So this point where the transaction obtained its last lock is known as a lock point. So this is a lock point. So lock point is the point after which the transaction does not obtain any more locks, and after which the only thing the transaction can do is to unlock. So if this protocol is followed, then we can say that the transaction is following the two-phase locking protocol. Now, two-phase locking protocol can still be improvised or made stricter, and to do so, there are several variants of two-phase locking protocols. The first such variant is known as the conservative 2PL or two-phase locking protocol, where transactions obtain all the locks before beginning. So that means from the beginning, if the transaction can identify that it's going to need data items A, B, C, D, and so on, then the transaction is going to obtain all those locks right at the beginning. The reason for doing this is because if the transaction has already begun and it has obtained, let's say, A and B locks and it is working, but then at some point towards the middle of the transaction, it requires a lock on C, but it's not available since it is being held by some other transaction. So at this point, what happens is this transaction has to wait for some other transaction to release that data item. And in the meantime, the locks that it already holds, which are A and B, are also useless because it's not able to use them, and at the same time it cannot unlock them because it's a two-phase locking protocol. You cannot unlock unless you've obtained all the locks. So in order to prevent such a situation from happening where resources are being wasted, we can implement a conservative 2PL strategy where a transaction will only begin if it gets all the locks. If it does not get all the locks, the transaction will release whatever it has and stop and not begin at all. So that is a conservative 2PL. Another refinement or variant of 2PL is known as a strict 2PL. Here, the transactions release all exclusive locks only after terminating. Now, if you remember the video on states of a transaction, then I explained over there that a terminated transaction is a transaction that has either committed or aborted. So in either case, the transaction is known as a terminated transaction. Now, such a transaction, if the transaction terminates, only then it's going to release the exclusive locks. So not before that. The reason for this is once again, releasing it before terminating might create some concurrency control issues and incorrectness in the database. So that is why this type of 2PL can be applied. So only exclusive locks are released after terminating, means after committing or aborting. And then we have the rigorous 2PL. So in rigorous 2PL, what happens is transactions release all locks only after terminating. So in this case, we are not just talking about exclusive locks, we are also talking about shared locks. So transactions will release shared locks as well as exclusive locks after terminating. That is called rigorous 2PL.